Hey class. So this week what we're going to do is see if we can clear up any confusion from last week. So we're going to run another experiment. This time all you're going to need is a regular old sheet of paper. So what we're going to do is we're going to demonstrate that the reason that the leaf hits the ground after the stick is actually not because it's lighter. It's because of something else. So I'm going to go ahead and show you how the experiment is done. So all you need to do is take your sheet of paper and you're going to drop it just nice and easy. So 1, 2, 3. Hits the ground after a long time, right? So that takes a little while. Let's try that again. 1, 2, 3. Takes a little while to hit the ground. But what if I take this same piece of paper and I crumple it up? Nice and crumpled. Now, see, I didn't add anything to the paper. It still weighs just the same as it did before. So it has the same mass, but we're going to drop it again and we're going to see if something different happens. That was a lot faster. Let's try that again. 1, 2, 3. Drop straight to the ground. Okay, let's undo that. Let's see if I can unwrap it here. It's not going to be perfect, but let's drop it again. It still floats down. So let's think about why that is. All right, everyone, so to understand how this experiment works, we're going to need to understand a couple of different types of forces. So we already know about gravity, right? Gravity is what makes that marker fall. It's a force from the Earth that pulls things with mass towards it, right? Really, it's a force that's from anything with mass. So you have mass, and so you have gravity too. But really, the big gravity that we're feeling is from the Earth and pulls everything towards it. So that's what makes things fall. But there's another force that makes things slow down a little bit, and it's called drag. So drag is a force that comes from the air. It's sometimes called air resistance, but we're going to call it drag. And it slows things down. So if you've ever been in a car and you hold your hand out the window and you can feel your hand get pushed back, that's from drag. So anything that starts moving really fast through the air, or anything that has a lot of area, starts to feel a lot of drag. So let's understand some things. So for our first experiment, we had our piece of paper, right? And so we have a certain amount of gravity. I'm going to use these arrows to denote forces. So each arrow is going to be a force. So this one is gravity. And gravity comes from mass, right? So that just is however big, however much stuff is in this piece of paper, that's how much gravity is going to be on it. But then there's a second force called drag that is going to say, okay, there's all this air touching the piece of paper, and all of that air touching the piece of paper is going to make a lot of drag. So just like if you were to have a tug of war and you have, you and your friend over here, if one person is pulling that way and another person is pulling that way, you're not really going to move it all that much. Maybe a little bit side to side, right? But it's not going to move as much. So that's exactly what's happening here. The drag is slowing down the piece of paper, which is being pulled by gravity. But when we did our second part of the experiment, we crumpled the paper up. It's going to be my crumpled piece of paper. We have the same amount of gravity because there's the same amount of stuff in it, right? But because there's not as much air touching it, see how that is smaller than this over here. There's less air touching it, less air pushing up against it. We call it less surface area that's being exposed. The force is much smaller. So this would be like if somebody in this tug of war was really strong, right? They have big muscles, And so they can pull much, much harder. So it's almost like this person isn't there at all. They can just pull that rope all the way over. So that's why most things, if you drop them from the same height at the same time, they hit the ground at the same time, because this force is so small that it doesn't matter. And the only thing that matters is the gravity. And the gravity is going to be the same based on your mass, right? But that's why this thing, why the leaf hits the ground later and why the piece of paper hits the ground later, is because there's so much drag, because there's so much more air touching it.